Good morning, students. I am Aher Alka from RBNB College from Physics Department. We start the chapter Gravitation, and in this chapter today we see the variation of acceleration due to gravity and variation of acceleration due to gravity at depth and at altitude. Now see what is the variation, what is the effect of G on the height and depth. Now consider first the altitude. Variation in acceleration due to gravity with altitude. Altitude is nothing but it is called as height. Now see, let suppose m is the mass of earth. M is mass of earth. R is radius of earth. Consider, suppose M is the mass of object situated on the earth's surface. Mass of object. Now see, G is acceleration due to gravity. Due to gravity. Initially we consider the object, it is rest on the earth's surface and of the mass m. Now we consider the object is on the earth's surface, on the earth surface. Now in this case, when the object is on the earth's surface, a gravitational acceleration acting on this, and we can say that the weight of object is balanced by gravitational force. Gravitational force. The gravitational force is given by Newton's law of gravitation. Weight of the object, it is nothing but m into g. That is, this is the weight of object, where m is mass of object, g is acceleration due to gravity on the earth's surface. Now the gravitational force from the Newton's law of gravitation, and it is given by F is equal to G m divided by r square, where m is the mass of object here, g is acceleration due to gravity, G m divided by r square, it is the gravitational force, where g is constant of gravitation, m is mass of earth, small m is the mass of object, and r is the radius of earth. The r is here, this is the radius of earth, this is the distance from center and the object where it is rest. Now weight of the object is balanced by gravitational force, and mg is equal to G m divided by r square. Now here m gets cancelled, we get G is equal to G m divided by r square. Now from this we can again read as Gm is equal to Gr square. Gr square. This is considered as equation number 1. Gm is equal to Gr square, where G is constant of gravitation, m is mass of earth, g is acceleration due to gravity, r is the radius of earth. This is the case when the object is on the earth's surface. Now we consider the object, it is at a height h revolving around the earth, and it is at height h. Thus we can say that r is the radius of circular orbit. R is radius of circular orbit. Now this R is equal to R plus H, where R is radius of earth and H is the height above the earth's surface and object or satellite of mass m revolving around the earth above the height h. Now we see is the critical velocity here. Now m, it is the mass of object or mass of satellite. Now in this case, again the force acting on the satellite, it is the weight of the object. Weight of the object or satellite, weight of satellite. Now GH is the acceleration due to gravity. Acceleration due to gravity at height h. At height h, and weight of the satellite, it is mgh. It is mgh, where m is mass of this object or mass of satellite and g is the acceleration due to gravity above the earth's surface, at height h. Now this weight of the object or weight of the satellite, or mass object is balanced by gravitational force. Gravitational force mgh is equal to gravitational force is gmm divided by r square. And this r is nothing but r plus h, that is radius of circular orbit. It is the summation of, or it is r plus h, that is radius of earth plus height h. Here again mm gets cancelled. Gh is equal to, we get gm divided by r plus h. R is equal to r plus h bracket square. Now substitute gm is equal to gr square. From equation 1 we get gr square divided by r plus h bracket square. Now gh is equal to, gh divided by g is equal to r square divided by r plus h bracket square. Again we can write gh is equal to this equation, g r square divided by r plus h bracket square. Now r square is taken common. gh is equal to r square in bracket r square, or 1 upon 1 plus h divided by r bracket square. Now in this case again we rearrange the equation. We get now gh is equal to, here we can say it is r square gets cancelled here, and we get g into 1 plus h upon r square. It is taken in the upward direction, it becomes 1 plus h divided by r raised to minus 2. By binomial expression or expansion, we can write this 1 plus h upon r is equal to g into 1 minus 2h divided by r. Now we directly write here gh is equal to g into 1 minus 2h divided by r. Now see, the 2h divided by r, or h upon r, is very less than 1, and we can say that if the height increase, altitude increase, the gravitational acceleration decreases. If as we go as above the height, that is height is increased, if h is increased, gh decrease, dh decrease. That is, we can say that as height increases, GH decreases. That is, we can say that at height h, GH is minimum. On the Earth's surface, the acceleration due to gravity is maximum. Now we see the next case, that is variation of acceleration due to gravity with depth. Now in this case, again we consider at depth, or we can say, suppose we consider here the Earth. Now suppose this is the radius of Earth and this is r. Again you consider the Earth is the concentric, it is a sphere and it consists of concentric ring. Suppose this is, as we goes towards Earth, this is center and this distance is, suppose d, this distance is r minus d, this distance is r minus d, and this totality is r. Now consider, suppose r is, m is the mass of Earth here, mass of Earth. Small m, it is mass of object, and it is inside the Earth. And suppose consider the Earth consists of, it is a sphere, it consists of concentric rings, and this is, suppose the mass is kept here at point P at the depth towards the center, and d is the distance from the Earth's surface towards the center. This concentric ring having radius r minus d, this is the radius of Earth. R is the radius of Earth. Now d is the depth. Toward the center. Now in this case, consider initial case, that is the mass is subjected or rest on the Earth's surface. First we consider the object is on the Earth's surface, that is, first we can say that weight of the object is balanced by gravitational force. Weight of object on the Earth's surface, it is nothing but mg. Again it is gm divided by mm divided by r square. Now in this case again mm gets cancelled. G is equal to gm divided by r square. Now here m is the mass of Earth, and we know, suppose m is the mass of Earth, v is the volume, rho is the density, then density is equal to mass upon volume. Now the mass is equal to, m is equal to volume multiplied by density. Volume of the Earth or volume of the sphere, it is given by m is equal to 4 pi by 3 r cube multiplied by this rho. Substitute the value of m in this equation, we get g is equal to g into, substitute the value of m, it is 4 pi r square, r cube divided by 3 into rho divided by r square. Now we get g is equal to g into 4 pi r cube into rho divided by r square. That is, it becomes r square gets cancelled, that is it is 4 pi by 3 g r rho. Now again आता consider second object is at the depth GD, it is the gravitational acceleration at depth, gravitational acceleration at depth. Then weight of the body, that is we can say it is again GD is equal to, we get G m dash divided by r minus d bracket square. We apply the principle of, that is weight of object is balanced by gravitational force, and we get the relation, that is GD is equal to G m dash divided by r minus d bracket square. Now here m dash can be written as, it is again volume multiplied by density. Volume of that sphere, this sphere is equal to 4 pi by 3. The radius is r minus d bracket cube rho. Substitute the value of m dash here, we get GD is equal to G into, substitute the value G pi 4 pi by 3 r minus d cube divide multiply by density and divide by r minus d bracket square. Then r minus d bracket square gets cancelled here, and we get GD is equal to G into 4 pi by 3 r minus d into rho. Then GD divided by G, it becomes GD divided by G, it becomes G into 4 pi by 3 r minus d into rho divided by 4 pi by 3 G into r into rho. G gets cancelled, 4 pi by 3 gets cancelled, rho gets cancelled, we get GD divided by G is equal to r minus d divided by r. GD divided by G is equal to r minus d divided by r, and it becomes 1 minus d divided by r, that is GD is equal to G into 1 minus d divided by r. This is the expression or gravitational acceleration at the depth of the earth. Now in this case, as the depth increases, now this value increases, G, that is gravitational acceleration, decreases. That is in both cases gravitational acceleration, if there is height increases, gravitational acceleration decreases. Here the depth increases, the acceleration due to gravity is decreases, and at the center the acceleration due to gravity is 0. Thank you.